Quotient rule. If y is equal to u over v and u and v are functions of x, dy by dx would be equal to v du by dx minus u dv by dx all over v squared. So the quotient rule is saying if you're differentiating a fraction where the numerator and the denominator are functions of x, and if we say that the numerator is u and the denominator is v, the gradient function dy by dx would be equal to v du by dx minus u dv by dx all over v squared. Example 31 says, given y is equal to x plus 1 over 2x plus 3, we're to find f1 of x. All right, and from the notation earlier, we know that f1 of x is asking me to find the first derivative. All right, so here we can see that we have what? We're differentiating a fraction where the numerator and denominators are functions of x. Therefore, we're going to use the quotient rule, which says that if y is equal to u over v, then dy by dx would be equal to v du by dx minus u dv by dx all over v squared. All right. So if I say u is equal to x plus 1, I'm going to say du by dx would be equal to 1. If you differentiate x, you get 1. If you differentiate 1, you get 0. 1 plus 0 is still 1. V, the denominator would be 2x plus 3. So dv by dx would be equal to 2. So dy by dx would be equal to v, which is 2x plus 3, times du by dx, which is 1, minus u, which is x plus 1, multiplied by dv by dx, which is 2, and this is all over v squared, which is 2x plus 3 squared. So this is going to come out to be 2x plus 1, 2x plus 3, and at the top we have minus 2x minus 2. That's applying distributive law. And this is all over 2x plus 3 square. At the top, 2x gone. So, and 3 minus 2 is 1. We have 1 over 2x plus 3 square. Let's go back up to the question. Alright. I'll go back down to the question. Okay, yeah. Essentially all we have to do is to find the gradient function. And we just did that. So dy by dx would be equal to 1 over 2x plus 3 squared. Let's have a look at the second one, but this time this time using the shorter approach. All right, so we have y is equal to x over x squared plus 1. All right, which is a quotient. So we have what? If y is equal to u over v, then dy by dx would be equal to v du by dx minus u dv by dx all over v squared. So let's apply that. So dy by dx would be equal to v is the denominator, so that's x squared plus 1 multiplied by the differential, multiplied by du, multiplied by the differential of the numerator, which is 1, minus u, which is the numerator x, multiplied by the differential of the denominator, which is 2x, and this is all over the square of the denominator, which is what? X squared plus 1 all squared. So at the top we're going to have x squared plus 1 minus 2x squared, and this is all over x squared plus 1 all squared. So therefore dy by dx would be equal at the top 1 minus x squared, and down by the bottom we have x squared plus 1 all squared. Alright, then we can say when x is equal to 1, dy by dx would be equal to 1 minus 1 squared, 1 squared plus 1 squared. So at the top we have what? 0. At the bottom we have 4. So this is still 0. So when x is equal to 1, dy by dx is equal to 0. Alright, here again we're differentiating a quotient. Instead of gradient, find the gradient function, and the gradient function is the first derivative. The gradient function is the first derivative. So we have y is equal to 4x plus 5 all over 3x squared plus 2. And again, if y is equal to u over v, dy by dx would be equal to v du by dx minus u dv by dx all over v squared. So dy by dx would be equal to the denominator, which is 3x squared plus 2, multiplied by the differential of the numerator, which is 4. The numerator is 4x plus 5. If you differentiate 4x plus 5, you're going to get 4 minus the numerator, which is 4x plus 5, multiplied by the differential of the denominator, which is 6x. And you divide all of that now by the square of the denominator, which is 3x squared plus 2. And this is squared. So at the top, applying distributive law, we're going to have 12x squared plus 8, and over here we're going to have minus, we have what, 24x squared, and negative times a positive is a negative 30x, and this is all over 3x squared plus 2 squared. Alright, so to finish, we have 8, let's put the positive number first, minus 12 minus 30. So we have 8 minus 30x minus 12x squared, and this is all over 3x squared plus 2 all squared. Alright, another example. Alright, example 34 says, find the value of a for which dy by dx is equal to a over 3x plus 2 squared, where y, so here y is equal to 2x plus 1 over 3x plus 2. Alright, again it's a quotient. We need to find the value of a. So again, the more I write this is the more I remember. So if y is equal to u over v, dy by dx is equal to v du by dx minus u dv by dx all over v squared. So dy by dx is going to be equal to v, which is the denominator, 3x plus 2, multiplied by du by dx, which is the differential of the numerator, which is 2, minus u, which is the numerator, 2x plus 1, multiplied by what? dv by dx, which is the differential of the denominator. So that is 3, and this is all over the square of the denominator, which is 3x plus 2 square. Let's simplify the numerator. Distributive law, we have 6x plus 4, and to the right we have minus 6x minus 3, and this is all over 3x plus 2 all squared, which is equal to 6x minus 6x, that goes, and 4 minus 3 is 1 over 3x plus 2 all squared, which is equal to a over 3x plus 2 all squared. So therefore a is equal to 1. Alright, so that is quotient rule.